the uh, contract and how to write the state and the flow framework. We also understood what are the internal components of the flow. Now let us get into some of the details of the components in Corda. We mentioned that Corda has state where we maintain shared fact. There is no single central store of data in Corda. Instead, each node maintains its own database. The result is that every peer or every node see only subset of the facts on the ledger, and no peer is aware of the ledger in entirety. So there is no central or a general ledger. Instead, every node in the network maintains its own vault containing all of its fact. So vault can be considered as a database or a table structure. And Corda provides the guarantee that whenever one of these facts is shared by multiple nodes, it evolves through a log steps. We mentioned about states multiple times, right? State is an immutable object representing facts known by nodes at a specific point in time. States can contain arbitrary data. It could be data about any arbitrary financial object or identity or any asset. And this information can also be about some real world fact. It can also contain reference to the contracts. States will have a sequence. So there is a life cycle of a state in Corda. When we need to update a state, we need to create a new version of the state, because in its existence, every state exists as an immutable entity. Hence, when we need to update it, we have to create a new version of the state. There are some states which we term as reference states. Not all states need to be updated by parties which use them. In the case of reference data, there is a common pattern which one party creates as reference data, which is then used by other parties. And hence, states contain reference data are known as reference states. They are not syntactically different from regular states. However, Corda treats them differently in transactions. We mentioned that Corda uses UTXO model where every state on the ledger is immutable. And ledger evolves over a period of time through applying transactions. Transactions update the ledger by marking 0 or more existing states as historic. So during transactions, either 0 or more states are termed as historic, producing 0 or more ledger states. Hence, it is important to understand there could be scenarios where 0 input and 0 output are produced. There could be 0 input consumed to produce 1 output. There could be 0 input consumed to produce 0 output or 1 output, or 1 output or more output consumed to produce 0 output. This is the flexibility in the UTXO model implemented in Corda. So when you look at this dynamics, transaction dynamics, a transaction can contain any number of input, output, and reference of any type. So the state could represent cash or bond or different kind of entities. There can be issuance. When you issue a insurance or when you issue a bond or a token, right? It need not consume any state. When your issuance of tokens are, when you do the tokenomics, right, in cryptocurrencies and different other entities, tokens are issued like, when you do initial coin offering or initial enterprise offering, initial economic offering, issuance of the token can be based on 0 input. But when you redeem it later, then you will consume states. We can also merge or split fungible assets like cash. Cash is a good example of a fungible asset, like a dollar. Transaction types. It's important to understand transactions are considered atomic, similar to databases. Either all of the transactions are accepted or none of them are accepted. So this is like all or nothing scenario. There are two basic types of transactions: notary change transactions and general transactions. When you want to change the state of a notary, state's notary, like that's a very important type of transaction. Other examples are all the general transactions. When you think about this transaction dynamics, transaction chains is very important. When you create a new transaction, output state, we mentioned about input and output state. If the output state doesn't exist, and if it has to exist, therefore, the proposer, the transaction proposer, has to propose it. And always input states already will be there. So we will include all the input states as a reference in a transaction. The input state references are constructed as a combination of hashing the transaction that you call the input. So when you call an input state, that corresponding transaction is hashed. And then we also calculate the index of the input as the output of the previous transaction. This is how the chaining happens in the transactions. So you can visualize this better in this diagram, right? Every latest block, when you look at it, right, blocks refer to previous blocks, and they will have their indexes, right? So when you are constructing a new transaction which refers to two old transactions, so the transaction hashes the output from the other old transactions, and it also generates the index. So this is like, you understand, right? We group transactions in a block in blockchains like this. We group transactions in a state object, right? And now we have seen the concept of transaction builders in the flow framework earlier, right? So initially a transaction is just a proposal to the ledger. It represents the future state of the ledger as per the reference or the template of the transaction builder. So for transactions to happen, it should receive the signature from all the required signers. We have seen how do we collect the input to the contract through commands, right? We can use commands. Each required signer append their signature to the transaction to indicate that they approve the proposal. Now comes the important part in validating transactions, right? Every signer required should be signing the transaction. So they sign the transaction when the mentioned conditions hold. The one condition is validity. Second is uniqueness. So how do you check the validity? For both proposed transaction and every transaction in the chain, which are created in the same transaction input, it should be digitally signed by all the required parties, and contractually it should be valid. We have seen how we enforce the constraints and how we check that constraints and validity through the domain specific language used by the contract, smart contracts in Corda. And they should be unique. There should not be any other committed transaction that has consumed any of the inputs in this proposed transaction. So this is how the uniqueness is ensured in Corda, or how do we prevent double spending in Corda. That's why UTXO is very, very important to prevent double spending in ledger like in the case of Corda and Bitcoin. Ethereum follows a different model where they construct different they construct state tries. So there will be a try for account, another try for a receipt, another try for, if you want to, I can show you the Ethereum data structure. Then you will understand Ethereum try data structure. Let me show you the diagram. Yeah, this diagram shows the Ethereum try data structure. So this is a simple diagram. Essentially, I think this shows you better. Yeah, this diagram shows better. Yeah, if you look at the Ethereum data structure, it has 3 trie. A world state trie. Oh, I think this is from, yeah. So, this is the trie from Ethereum. World state trie, receipt trie, and transaction trie. So this is something called Merkle-Patricia trie. This is how the Ethereum data structure is entirely different from Bitcoin UTXO model and the Corda UTXO model. You have states, account states, transaction trie, and receipt trie. So every transaction receipts are separate, transaction trie is different, the state is different. This is the difference between Ethereum data structure and the Corda data structure. Okay. Now, when you come to this, right? So we see how we verify the validity and uniqueness. Now, in the input and output, a transaction contain commands, attachment, time window, and notary. These are the advanced components we use in a transaction. So when you see a transaction with an input going to an output, the command that we execute in the transition is called the command of the particular transaction. So there could be here we are seeing a command for settlement and payment and settlement commands in the transition where Alice pay Bob £5, right? So that is the example, right? One is payment and second is settlement. There are two kind of commands what is executed in the transition from the IOU input output U1 to U2, right? Essentially, there is a cash transfer happening. So cash data is changed and the transaction state is changed. And then we also have ability to attach objects. For example, you want to attach the receipt or a bill or an invoice in this payment, you can attach it. There window in which you should complete this transfer. If you don't do it, you're liable to pay the interest. And then you append the signature of the parties, Alice and Bob, in this. So this is the example mentioned here. Alice need to pay a cash of $5 to Bob, and they're using input-output UTXO. This transaction comprises 2 commands: settlement command, which reduce the outstanding amount on the input-output state, and payment command, which transfer the ownership of £5 from Alice to Bob. So transfer of ownership happens, and the settlement, which settle the balance. And then you're including to attachment, which has to be notarized by the notary which is used here. And the notary pool should receive it within the time window. So transaction commands allow us to indicate a transaction's intent, affecting how we check the validity of the transaction. Each command is associated with a list of 1 or more signers by taking the union of all the public keys. So there is kind of a public key aggregation happening, which is helping us to ensure when you have multiple parties signing the transaction, all their keys are aggregated. And what are the concepts of attachments? Attachments are either zip or jar file, which can contain arbitrary content. It could be images. Recently, when I did an auction, reverse auction in Corda, they wanted to attach the photo of the people who are participating in the auction. You can also add their consent. You can add their membership registration. All relevant documents and attachments can be added as a zip or a jar file. Okay, so it could be a calendar, a legal documentation, a table of currency code, or any other example, they can be referred by the hash of the attachment. When you check the validity of the transaction, these files can be used. Now we come to the concept called transaction time window. Here we want a proposed transaction to be approved only during a certain time window, like example of option in a trading or redeeming a bond before the expiry date. So these could be examples of time window based transactions. Time window specify the time period during which transactions can be committed. Like we mentioned, like the command, like the earlier we mentioned, the notary pool enforces time window validity. So what is this notary? A transaction notary is a network service that provides uniqueness consensus by attesting a given transaction that it has not been already signed other transactions that consume any proposed transactions. So it is an assurance from the notary that it has not signed any other transactions which uses the proposed input. So the notary pool provide the finality also. We mentioned about finality flow earlier, right? So notary pool helps us to get the finality in the system. So if the notary entity is absent, then transaction is not notarized at all. Hence, this is the scenario when issuance of transactions that do not consume any other state. So when you do a kind of genesis transaction, or when you do some kind of such migration, for example, you are setting the initial data in a land registry or in a medical registry or in other birth registry or any other registries. These scenarios, when you want to set up the initial state, genesis state, you can do it without involving the relevant parties. And then let us also talk about that transaction verification. How do you verify the transaction? We should know that transactions can be verified only if it is digitally signed by all required signers, right? So even if it gathers all the required signers, it is valid only if it is contractually valid. Now the question is, how do you validate the contract validity? Each transaction state specifies a contract type. And we have seen how do we pass transaction as input to a contract. And a contract also states whether the transaction is valid based on the contract rules. So the constraints and the agreements and the domain specific language terms mention what is the validity of the contract. And third point is the transaction is valid only if the contract input state and output state is considered valid. So input state and output state should be valid. And then, so the specification, because we specify the input state and output state. So the input state and output state should be valid, and the contract type should be valid. A contract should take a transaction as input, and then contract rules should be enforceable. And what are the capabilities of the contract? Contract has the full capabilities of the domain specific language used in Corda to check the number of input, output, command and attachment, checking whether there is a time window, checking the contents of the components, looping constructs, variable assignments. We have seen how to include loops, variable assignments. We can also add helper methods when you want to add additional objects or utilities. We can do through helper classes. We can also invoke a lot of functions. And we group similar states. We can also group states and aggregate states to validate them as groups. For example, when you are doing an auction, you want to group the bid from a lot of parties. You can do grouping of the inputs And then you can also impose a rule on the combined value. For example, if you are getting bid from all of them, you can check if the bid, all the bid is above a particular value. Or if you're taking the supply chain and you're checking all the retailers and checking whether they have signed a contract or agreement, or they have the necessary, they are coming within a particular distance range. All those conditions can be validated across the group. Contracts can also be, it is important to know that Corda uses the concept of deterministic Java virtual machine. It's called deterministic JVM, right? Because the transaction verification in Corda should be deterministic. You know, what is the opposite of deterministic? It is probabilistic, right? So it cannot be a probabilistic consensus or probabilistic commit. If you see the case of Ethereum or Bitcoin consensus, their commits are more probabilistic. This is the main difference between most of the permissioned ledgers and permissionless ledgers. Most of the permissionless ledgers, like Bitcoin, Ethereum, EOS, etc., they all use consensus, which is non-deterministic or probabilistic. Even though it gives a good commitment on the finality, it is not 100% assured, like in the case of Hyperledger or Corda. Corda hence use the concept of deterministic Java virtual machine, right? You can read more about deterministic JVM here. Let's say deterministic JVM Corda. Yeah. So you know there are a lot of articles on this. I will give you this example, right? What are the chances of non-determinism, right? So it is important all the nodes that let me give this data here. Corda uses deterministic JVM. Okay, so this means that all the Corda, all the nodes that process transactions should always agree whether it's valid or not. So the JVM, Corda Java virtual machine, is engineered such a way that the execution of bytecode must be fully deterministic, right? You know, there are different kind of compilers, right? If you look at some Ethereum virtual machine supports probabilistic execution of code. This is the difference, right? The Turing machine itself, right, is a kind of probabilistic Turing machine, because the consensus, whether it's proof of work or proof of stake, is a probabilistic consensus where there is a good chance, and that chance determines the success of a party or success of the agreement. But in the case of we should know that out of the box enterprise JVM, what is used in Java by default, is not fully deterministic, right? So that modification is done by Corda. How they have done it? They eliminated chances of non-determinism, like there is no random number generator execution here. You can't give external input to the JVM, like external clock or network input output, or any additional is file system integration. The halting criteria, this is what we mentioned about the Turing machine, right? If it is a fully Turing machine, fully qualified Turing machine model or a Turing complete model, you should accommodate scenarios where there is a recursion and halting, right? How to terminate long running programs. Such a model is not there. Recently, Corda in the latest 4.6 version, they introduced something like killing the long running or dead flows. And right, also the way multi-threading is implemented in Corda, that is also deterministic. And it also garbage collector callback, this is also eliminated. So we mentioned about the contract sandbox, which is used in Corda. It is implemented in such a way that it is always every contract is executed in a deterministic JVM sandbox. You can read more about it here, and there is an interesting article on Corda JVM. There is, you can find the entire source code of you know Corda's deterministic JVM here. It will be interesting for some of you who are more interested in performance tuning and Corda engineering. Corda DJVM. This is a blog article. That would be a good reference. Okay, so you can see how to test a deterministic JVM, right? And in the latest version, they have implemented a lot of additional features on the deterministic JVM. So you can find the example of how the deterministic JVM is implemented and how it is used. Okay, now let's get back on the presentation. So when you read about this further, right, about the deterministic JVM, you understand we use it predominantly for contract sandboxing. Sandboxing is a concept where you deploy something for a testing purpose or experimentation of its features. So if the transaction validity cannot depend on the time which the transaction is conducted, so you want to make completely shield from any temporal effects or time sensitive effects or the amount of information on the peer running the contract. So this is very important, and especially when you are implementing some advanced cryptographic libraries, time independent. So like we talk about the concept of delegating computation, right? You want to delegate some computation to some parties. We want to make sure that that is independent of the time in which it is run, right? So deterministic sandbox is the concept where this sandbox prevent the contract from importing libraries that could be a source of non-determinism, like random number generators, file system access libraries example. So ultimately the time when the contract is executed is it has only information necessary for verifying the transaction and checking whether all the transactions included are correct. It cannot do anything non-deterministic and asynchronous at the time. So this is a partially synchronous construct. This is very important to understand. We execute the contract in a partially synchronous manner, eliminating all kind of possibilities for non-determinism. Corda flow. So, now when you look at the latest upgrade to Ethereum and the other chains, we can understand they are all trying to leverage randomness in different way inside the contracts. But that is a different direction from the way in which Corda is going. Because Corda, this is very important for regulatory point of view to ensure that there is a good determinism on the terms and references mentioned in the Corda contracts. Now let us get into the very important concept we studied earlier called Corda flow. Flow automate the process of agreeing to ledger updates. It is the communication between node that occur all the node communicate to each other through these flow, and this is point to point. We mentioned it uses something called AMQP. So essentially, there are built-in flow which are used for automating common tasks. It has built-in flow like system chain code so please don't mix it with the Hyperledger chain code. There are built-in flow and developer written flow in Corda. Flow framework. So every flow is part of the flow framework. So this is an automation for the way we mentioned about how Corda implements the flow. It uses a framework called Quasar for executing the flow. Quasar schedules and it provides an automation, right? Corda automates the flow. A flow is a sequence of steps that tells a node how to achieve a specific ledger update. Once the business process is encapsulated in a flow and is installed in a node as part of the Corda app, the node owner can instruct the node to kick off the business process at any time using an RPC call or a REST call. Flow abstract all the networking, input, output, and concurrency issues away from the node owner. This is a very powerful feature that the node owner has only to worry about writing the sequence of business logic. The node owner doesn't need to worry about networking, input, output, packet exchange, messaging, routing, and all the concurrency issues. So flow framework, when you look at the flow framework, every activity on the node happens through this flow. It is different from contract. Flow contract is executed in a deterministic JVM sandbox, but flow is not executed in a sandbox. Flow has all the capabilities for, asynchronous execution, multi-threading. This is very important. Whatever we have seen about Java Fiber and Java Quasar and Java multi-threading, which is all prevented or not used in contract, that is all used in flow. So all the node can, whatever actions such as networking, messaging, routing, input, output, source of randomness, whatever is required, can be done in the context of the flow. So node communicate to each other by passing message between this flow. Each node can have 0 or more flow clauses, which are registered to respond to messages from a other flow. So, and also we can construct, flow, subflow, like we can have a hierarchy of flows. So flows can be composed by starting a flow as a sub-process in the context of another flow. The flow that is started as a sub-process, we call it a subflow. So parent will wait. That's why we have an await instruction, right? Asynchronous, it can asynchronously wait for subflows to complete. So the flow library consists of flow library is internally used in Corda to handle common tasks. So they don't need to work on writing code to handle trivial automation task in the Corda, because that is all taken care, like notarizing and recording a transaction, gathering signatures, executing finality, right? Initiating a transaction, gathering signatures from counterparty, verifying a chain of transactions. And now we talk about concurrency in flow. So flow framework allows nodes to have many flows at once, active at once. That is why we mentioned about killing some of the stale or dead or orphan flows. These flows may last days. Contract execution, we have to do synchronously, but flows can exist, may last for days across node restart and even upgrades. So the flow is persisted, right? This is achieved by serializing flow to disk whenever they enter a blocking state, when they are waiting on input output or a networking call. So if there is a remote procedure call or a kind of routing message, or it is waiting to complete an input output action, like encrypting a file or sending, doing a schedule, right? Or it can enter a blocking state that will be serialized to the disk. So instead of waiting for the flow to become unblocked, the node can start working on other scheduled flow, only returning to the original flow at a later date. Now we come to the other important concept known as vault. Each node on the network maintains a vault, a database where it tracks all the concurrent and historic states that is aware of, and which is relevant to itself. So this is how we depict the how the states and the contracts are working with the flow. State will have the reference of the contract. The flow will mention everything about how it is initiated, how does it get the data from internal systems, how does it get the data from external oracles, how do you create transaction, how do you sign transactions, how do you, so initiator and the responder, these are two important objects in a flow, right? So when you look at the flow internals, you know about initiator and the responder, right? And and then the flow, when you are entering into a suspended state, when you checkpoint and suspend a flow for some time for completion of some transactions, then it is suspended, and then once it is resumed, you complete the inspection and verification, then you commit the transaction, then you end it, right? So the concept of initiator and responder also is an important concept. So when you look at it, you can see that this is about deterministic JVM, and this is what I shown you about. Yeah, this is the initiator or I'll give that reference here. Initiator and responder in flow framework. Okay, so this concept means we have to, initiator will initiate the request to update to the ledger. Responder will respond to the any request for update in the ledger. So this is very important. You must have understood it by the concept by now, but then I just wanted to highlight it, right? So Corda node, this is the architecture of entire Corda node that we have been referring so far, right? Corda app is the web application or the mobile application. You can have multiple Corda apps using the same node infrastructure. So here we are seeing the example of a Corda app that talks to the Corda services through RPC. It could be JSON RPC or XML RPC. The node infrastructure management console will also talk to the Corda node, Corda services through the RPC. Then the services interface, part of the service hub, will route the request, RPC request, to respective service like messaging service, system management service, notary service. There is also a component called secure guarded extension, SGX. If you want to execute some remote attestation of contract or remote verification or encrypted smart contracts or any encrypted highly confidential operation on Corda, that can be done through SGX hardware. That is an additional component. It is available in enterprise version of Corda, but there will be an additional expense to it. It's called secure guarded extension, SGX. Or the key, private public key management is also done in key management, and then we have the flow framework also part of the services, flow API. Then identity services are there, Vault is there. All of them are connected to the sandboxed deterministic JVM and the operating system on which the Corda node is hosted, or the Docker container or Kubernetes container. And then there is a backend relational database. There is an LDAP registry, user registry, and other management and reporting tools. Then there are also private partner networking tools and message queues. The reporting tool, when you use the enterprise license, you will get access to these reporting tools. They directly access the relational database, be it PostgreSQL or MS SQL or MySQL or whichever database, relational database that you're using. So Corda nodes run flow to update the ledger. That is why we need to understand how this flow framework work? For example, there is node A, node B, and notary pool. See, in this case, the node A proposes an update and it checks the update and sign the update. Once it is signing, it is sending to the other node for checking and signing. It is signing and returning to, so initiator is the node A, responder is the node B. Then it's responds back to node A. Again, node A initiates it to notary pool. Notary pool is the responder. It signs the update and the node A record the update. And then once the node A records it, node B records it, then that's end of it. So we know what is the role of the initiator, responder, and the notary pool. So when we see this architecture, right, we can understand nodes, right? When you look at the flow framework, right, you can kickstart a flow from an RPC code. So it need not be a Corda app. You know, if in case some case you are integrating Corda app to a third-party application, in that case, it can be yes. I will share the PPT to everyone. You know, I can share it in this at the end of the session. If you want, you can access it online. Probably, I will. I think it is better to share it like in an email. Which one is better, sir? You want me to share it online or through email? Yeah, probably if you want to access now, I can share it. You know, I can share the link so that.
Sir, we can email to the participants also.
Yeah. I can give you at the end of the session. I can download and give you. Now for everyone, I will give you the link so that you can real times view it if you have a good internet connection. Okay, I've given the link so you can access it. And then after the end of the session, we will email to you the presentation. Okay, so we were talking about how to call the particular flow. We can call it from RPC call. You can even call it from STTP or REST, right? So you can write different APIs. It can be HTTP or MQTT or XMPP or any other protocol to call the flow framework. The flow starts, then we build the transaction, and then we sign it, and then, you know, after you sign it, it goes to the next party, counterparty, and they verify the input, and then whatever checking they want to do, they will do it, and then notary will do the notarization, and then it's recorded in the vault. So every node has a vault and a transaction storage. It will be stored there. So you can also query the vault. That is an important concept you should know. Everybody can query the vault. So, you know, sometimes auditors want to audit the Corda application. Then you don't need to give access to the smart contract, business logic, or the state and the flow, but you just need to give the access to the vault. Vault can also be exposed through RPC call or through other APIs. So what is this Corda consensus? We mentioned Corda uses two kinds of consensus: validity consensus and uniqueness consensus. So validity consensus is checked by each required signer before they sign the transaction. And uniqueness consensus, this is checked only by the notary. So notaries and consensus. Notaries can also implement other consensus algorithms for checking we know notary validates uniqueness. Notary by default implements one consensus. If you want, you can have notary implementing Raft consensus or Kafka or even some Hyperledger Sawtooth uses proof of elapsed time. If you want, you can add proof of elapsed time. So the proof of any consensus can be plugged in, as Corda supports. You can plug in any consensus in the notary. So notary currently implementation is one called OneBox. This is for the local environment. And then the Raft consensus. Raft is crash fault tolerant. That's why Raft is recommended for Hyperledger. Fabric also implemented Raft recently in their version 2 from 1.4 onwards, right? So Raft consensus is useful. And recently we are seeing Corda is planning to add other consensus algorithms like BFT Smart. So when you talk about the Corda security, right? Corda do provide extended security, like they provide TLS based authentication and key stores. You can see here Corda in enterprise version, they use one signature key store, trust store at the client level. So RPC communication itself is protected. There is an RPC SSL key store. So every RPC communication is encrypted through secure socket layer, STTPS, and any RPC call comes to an RPC broker. It's a point-to-point communication, right? So Artemis brokers are used, and then any communication, there is a bridge, security bridge. So the communication between the node and the bridge is also through that's a peer-to-peer communication. They use peer-to-peer message brokers. And so there are two kind of security storage in every node, trust store and SSL key store. And in the bridge, there is one more level security. It's at the firewall trust root. So one is at the RPC, another one is at the SSL R3. The red one indicates R3's trusted certificates. Violet color or the purple color indicates the firewall trust certificates, and the blue color indicates the third-party trust certificates for the RPC, right? And then after the bridge, there is a float. So every communication between every node and its peers, the communication happens through a bridge and float. And the key authentication is happening through the encrypted channel between the bridge and the node, but there is a secure tunnel between the bridge and float. And float is directly communicating to, so every inbound call from the peer comes through the float, and every outbound call goes through the bridge directly to the peer. This is the communication security model in Corda. So when you look at the Corda enterprise security on a high level, we can see there is a demilitarized zone where the Corda firewall will be there. And then there are two kind of firewalls used by Corda, right? One is the float and the bridge. So both are made to be high available. And then, so we saw that in how the inbound outbound connections are handled by the float firewall and the bridge firewall, right? So finally the node connects to its own messaging core and the ledger data. Okay, so when you talk about the Corda vault contain the states, right? Whatever states we mentioned, it stores in a relational model, right? The consumed historical states are grouped together. So that is, all the consumed states are put it into the current state. So we will have both consumed historic state and unconsumed states in a vault. So you can see that entire, when you look at the network architecture, client talks to network service map, part of the service hub. From there, there are network service man and the doorman, right? So in client talks to the node or through the Corda app. Corda app is hosted in the node with deterministic JVM. If you have oracles, your oracles will be talking through the Corda app. And then notary, some notary node. So you can see notary node and nodes which use Oracle here. So through doorman, they talk to each other. Okay, so now we talk about the Corda apps, right? We have seen this earlier. What all components are there? We have services, contracts, states, whitelist, and the flow in the Corda apps, and they will also have the default flows, right? We have the user written flow and the default flow, user generated flow and the default flow, right? They all talk to the node through Service Hub, and every RPC call from clients come through the RPC client. So and then Service Hub is connecting to Vault, storage service, flow, state machine, identity management, key management, scheduler, network map, and the notary and the messaging, right? For persistence, we can use SQL, any relational database like PostgreSQL, Oracle. Recommended to use PostgreSQL, also supports Oracle, right? I've seen by default people recommending PostgreSQL, but we can also use Oracle and other relational databases. So this is how we can also use other additional services like notary change service. If you want to change the notary, right? We can also plug in services. We have seen some of the references where plugins are used. Otherwise, this is the same architecture. So when you look at the overall Corda structure, right? The network structure, all the participants there, for example, banks, we mentioned about banks, there could be all the participants plus notary plus network map and identity operator and then Oracle. So and these are the essential components of a large scale Corda implementation. So it is important to understand all the participants talks to the Corda network, to external network through firewall. Then we will have identity operator, which takes care of the certificate authority and certificate installation and secure communication. There is a network map which allows to map the IP address to the identifier. And there is an ordering service. It is not specifically ordering service, it's not tracing service. It doesn't use anything like proof of work or any probabilistic consensus. And there is an Oracle, right? So these are the essential components. So we have seen the flow concept in detail. We have to understand it is point-to-point communication using AMQP based routing. And we have mentioned flow. In flow, we do messaging, signing, verifying. So the Corda main flow, we have seen this, how we build it, verify it, how we initiate subflows, gather counterparty signatures, and then what happens to the old state and how do you do that? How do you include state references? How do you invoke commands? Transaction lifecycle, we have seen state, transaction, consensus. And then, yeah, we have seen this concept. How do we use transaction builder? Builder will inspect content and then signatures are collected. We have seen what is in a transaction. There could be issuance transaction where there is no input. There is exit transaction, there is no output. So you can have zero input or zero output. Issuance transaction is an example of no input. Exit transaction is an example of no output. There could be update transactions as well. So when transactions happen, contracts verify whether the state change satisfy all the conditions and then attach the signature. So first you compute the state using the flow, or you can execute off-chain logic. That is the power of flow framework, because it can interact with the external system. And then you invoke the contract verifies the state change, and then you sign the transaction. You can have separate logic to create the proposal. You can collect as many signatures as you want using flow framework, and the contract verifies the state change. So we have seen about the transaction proposal and the finality flow. So uncommitted transactions are proposals to update the ledger. And then to commit a transaction, it must be signed by all the peer. And then here the Alice proposed a transaction, which is signed by the peer node. And then Bob signed the transaction next. Transaction is then sent to the notary. And then if all the required signatures are gathered, transactions are achieved validity consensus together with the uniqueness. So validity comes first and then comes uniqueness through notary. So this is how we have seen this, how building transaction, signing it, verifying it, gathering counterparty signature, notarizing as part of the finality flow, and then recording transaction as part of the finality flow, right? So after, in the recording phase, you can see you are sending it to transaction storage and vault and sending the update to the counterparty. So you can see the arrows. When you're gathering the counterparty signature, how does it happen? Okay, and verification of transaction happens on the node itself. That is the main security of the system. So transaction signature, first level signature is happening inside the node. Second level verification also happens inside the node. Then if you want, you can collect the counterparty signature, and then after that you can record the, even when you notarize it, right? Notary signature, notary verifies the signature which is done earlier. So this is the secure overall work transaction life cycle. The state management, we have seen how does it happen in Corda, right? State objects are updated. There are code, legal contracts, events, and parameters. So these are the components in the state objects. Code, the default code that you write, and the legal constraints that you mention, the events and the parameters. There is an interesting question on, can we use Corda apps to create framework for Ethereum education? It is better to use Corda applications on Corda itself. There is a way in which we integrate Corda with Ethereum, which I can show you. But Corda application directly cannot be deployed on Ethereum virtual machine. That is a challenge. But Corda apps with an interface through can talk to. So there could be a Corda app with a Corda node doing some part of the work and then including some other part of the work from Ethereum. That is possible. Okay. Setup to interact with an Ethereum. Difficult for a Corda I'm just responding to a question. Okay, so there is another important, good question on the Corda scalability. From my implementation experience, Corda is very scalable. I had done a reference implementation. Couple of implementations. When I have done it, even in the simplest, simple, the infrastructure with 8 GB RAM, I got more than 1,500 transactions per second. And the main scalability is two-part. One, the Corda data structure is very simple. Secondly, the Corda, the way you sign a transaction is very simple. The digital signature in Corda is very lightweight. That is one aspect of the scalability. Second, Corda doesn't use the massive, heavy gossip protocols that is used in Ethereum and Hyperledger. Hence, it doesn't have that communication overload or the messaging overload that we have in the case of Ethereum or in Bitcoin, even though it also uses UTXO. So there are interesting aspects. UTXO is the Ethereum, Bitcoin UTXO is lighter than the TRI model in Ethereum. That is why Bitcoin data management is simpler than Ethereum. But Bitcoin uses gossip protocol. Ethereum uses gossip protocol. It is not only an engineering choice. I would say it is also because of the way they want to implement decentralization. See, Bitcoin is designed as a simple money transfer system. You are not, it is not designed to execute smart contracts. That is why they have a simple UTXO model. Secondly, Bitcoin doesn't want to, Bitcoin doesn't want to do smart contracts. That's why it doesn't have the TRI model. The TRI model where you have world state. You have seen that Ethereum TRI model. There is a separate TRI for received, another TRI for world state, another for account. That model is not necessary for Bitcoin, but it is necessary for Ethereum because Ethereum want to process smart contract. Now, when you look at Corda uses UTXO because Corda want to do payments like Bitcoin. Corda is using smart contracts, but not the Ethereum way. It doesn't implement the TRI model, whereas it implements the flow framework from Java, right? So that is the reason Corda is more scalable in the current format. And Corda, there is individual node takes care of its history. It is not storing the history of everyone. So it is lightweight compared to Ethereum and Bitcoin and Hyperledger. That's why they're able to scale faster. When I was getting around 1,000 1,000 transactions per second, very difficult in Hyperledger with 8 GB RAM, I got more than 1,500 to 2,000 very simple with simple configuration in Corda. So at the moment, Corda is doing very good in terms of scalability, but they are planning to get more because every distributed ledger at the moment want to become the next Visa or MasterCard. Now there are protocols like Elrond, which has already achieved 10,000 transactions per second. Like Hashgraph also achieved 10,000 transactions per second. And there are a lot of other side chains like Near protocol that has got more than 2,000 transactions per second in on the Ethereum like infrastructure. So that means scalability at the moment, Corda is doing a good job, but they are still trying to refine it further for large scale implementation. But there is one catch. None of them, like Corda or Hyperledger, doesn't have a live infrastructure with 10,000 node that is in the Ethereum or in the Bitcoin. There are 10,000 nodes mining real time every day, every minute. Such a production infrastructure doesn't exist for any of them. Bitcoin, the size itself is more than 230 GB for every node. But then, the focus of Corda is different. That's why they have engineered in a different way. So this is what we have seen already. We have seen how we can execute different commands. This is an example command where we transfer, we do the payment and transfer the coupons. So this diagram shows all the property. How do you encode properties of a state, and then how do you have a reference state referring to a contract, and how do you do that state sequence? In how can you see that state sequence in a vault in Corda? So these are some of the points we mentioned in Corda, right? The Java concurrency, and how do we use Quasar, and Quasar is the Java library for concurrency. And then Corda, every Corda constructs can be suspended and then they can be resumed later. So Corda uses the concept of fiber. Fiber instead of thread, we use fiber in Corda. Corda is not like multi-threading by default. It is using fibers in Quasar, which is implemented by Parallel Universe. So this is about Java concurrency. Quasar fibers are used. We use it with suspendable annotation. We park and serialize them when they are suspended. Then we can resume it later. Corda also uses the concept of state machines, a very important concept, right? State machines are, Corda state machine is different from Ethereum state machine model, right? Ethereum uses a different state machine model, Ethereum and Hyperledger. Corda uses state machine only part of the flow framework. That state machine is a wrapper on the Quasar, and then it can either, you can either write the code in Kotlin or Java in the flow logic, and the Corda app refer to the flow logic. Current state of the flow logic can be checkpointed. You can resume it from any checkpoint. State machine in Corda is having an event feed, and then it is executing the events like a thread. Events trigger transition between possible states. Every flow starts in pending state as a start of the flow message, and then transitions to running. And then finally, we achieve finality at the end of its execution. And once the checkpoint is done, the data is cleaned up. So this is an example of how the Corda state machine works. So, it is, once it is running, if it is suspended, you can resume it. If there is an error, it can either go to fail state or held state, or you can move it to pending state and try it again. And finally, it can be success. So Corda, when you model a system, first you have to define the state, then you define the contract, and then you define the flow. Okay, so this is the way you implement Corda integration. As we mentioned, we can use another different databases. Basically, Corda uses relational database, but in some cases, we can use non-relational database for notaries. That's a exceptional scenario. Normally, Corda nodes and notary workers work based on every node will have a database. So you can, Corda nodes talk to notary workers as part of a notary pool. By default, there could be a database. That could be, that has to be a relational database. And then you can also use another database for reporting purpose along with the notary in a very highly scalable infrastructure. I'm not talking about a very simple implementation. If you have a large scale system where you need a lot of notary workers in the notary pool, so many transactions happening, right? For example, like a B3A consortium where you have, or R3 has a banking consortium with 80 banks, like the large banks like JP Morgan. They are also doing a payment gateway integration with Swift. Such a systems will need large scale notary pools. So this kind of an architecture is recommended for such models. This is I'm just showing, there was a question on how do you integrate, or what is the possible interoperability between Corda and Ethereum? Like we have a ERC token standard in Ethereum. We have flow framework in Corda. dApps in Ethereum, we have corresponding core dApps. In Corda, we do UTXO states. Ethereum, we do smart contracts. And every account has an address in Ethereum. If we have node addresses in Corda, node configurations are done. Ethereum has something called Ethereum naming service for naming the smart contracts. And then Doorman is the registry of identities in Corda. Corda also have a network map and notary. Ethereum, on the other hand, uses consensus algorithms. So, this is how we do, how can we relate between Corda and Ethereum in terms of the functionalities. So I've tried to include some of the additional components here, but then I think I've covered most of the points required, essential points for you. I hope you will start building contracts, schemas, flows, and states. Once you've done all that, your Corda app backend is ready. Then you can integrate that with any web application that you write in Spring Boot, React, Angular, or any other UI framework, right? So now the next part is only about building a good user interface, mobile app or a web app. You can either do mobile app in Xamarin, Cordova, PhoneGap, or any other framework. Flutter, you can also use Flutter. Any like mobile app or web app like React, Angular, or Spring Boot or anything can be used for the front end. So with this, I would like to conclude the session till now. Would like to know your questions and comments and your ideas and inputs. Over to all of you.
Yes, if anybody is having any doubt, you can have it.
Participants can ask the...
By the way, I would like to share with you, I have a Telegram community on blockchain. It's called Epic Blockchain Collective. I will share that link with you. It's been running since 2018. So you can find information related to blockchain, all the discussions from 2017, 18 onwards, you can find here. You can join here and, you can participate in discussions with everyone. It's a big community. I mean, it's not very big community, but you will have a lot of information on blockchain. If you are if you would like to connect with me, you can always connect with me through our Twitter. We have a Twitter community called on blockchain. I have a Twitter community called Fusion Ledger. You can all connect with me in Twitter. And if you have any more questions, like when you're joining this Telegram community, please note there is a cloud captcha bot. So all of this is just to avoid, we get a lot of joining requests from bots and automated spamming bot. That is why I've installed a cloud captcha bot. Kindly request all of you to do the captcha verification when you're joining. It takes hardly 1 minute. Once you do the captcha, you will be able to join it. Kindly do the captcha. You can join the group, and you can always connect with me on Twitter personally and for any discussions. And you can also connect with our community. I run a community called Epic Knowledge Society. So, it is also there in LinkedIn. You can visit our website. We do a lot of programs on blockchain. We do hackathons. We form teams. We participate in hackathons. And we are also on LinkedIn, Epic Knowledge Society. It's a great opportunity for me to interact with all of you. So it's really an honor. So I wish you all the very best. I am looking forward to seeing a lot of students coming from all of your campuses, and then taking up blockchain. And I also, if you are doing your researches, if you are setting up labs on blockchain, I'll be happy to assist you, guide you, support you. Once again, thank you so much. If there are any questions, I can answer. Otherwise, please post them in the group, WhatsApp group. Yeah, there is a question on, there is a question. Can I move to Corda directly without knowing Ethereum? Yes, definitely possible. You don't need to know Ethereum for working on Corda, but it is good to work on more than one blockchain to compare and contrast with the efficiency and the performance. Corda is the learning curve is very small. You can get started with Corda within 2 days or 1 day, I would say. If you're familiar with Java or Kotlin, getting started with Corda is very simple. And Ethereum, you need to study a little bit more. Ethereum, but advantages, there are a lot of online materials available. Corda, there are good books and materials available, but then, and also the online GitHub repositories are very good. But then I would say you should try more than one blockchain protocol. So if there are, sir, is there any more questions? I am not able to see questions.
I think there are no more questions, sir. So,
is it? I'm missing them.
So that indeed was an enlightening session on Corda. I'm sure participants have acquired knowledge about the basics of R3 Corda platform, like architectural standards, features provided by Corda, and how to write a state contract, what is the significance of flow framework, architecture of nodes, etc. Thank you, Gokul sir, for the wonderful session. Now, we are moving to the closing ceremony of this training program. For the kind attention of participants, the link for the assessment test will be shared in the chat box soon. Please make sure that you attend the test, as it is mandatory for issuing participation certificates. First of all, I would request volunteers from participants to share their feedback about this training program. Any volunteers?
Can I?
Yes.
Please.
Yeah. Thank you for giving me this opportunity to let me share my feedback. First of all, I'd like to thank Dr. Jubilant and his team for organizing such an event. I felt it was a wonderfully curated and a holistic event. We covered everything we should have to get to a platform where we can dive deeper and go further. We had sessions from bitcoins to consensus algorithms to blockchain applications in various domains, collaborative innovations, and also putting up some ethical values regarding blockchains. I might have skipped a few of the sessions, but this is like the kind of depth or the breadth I want to cover. Sessions were being delivered from experts from different sectors of the industry, which in itself speaks about the breadth of the content we learned over the last week. I'd like to thank all the speakers. Some of them were from different geographies as well, and putting up their lectures in early mornings, which was quite motivating to see. Also, a special thanks to Mr. Tibin and Mr. Gokul for taking us through a hands-on experience today. It was quite enriching, and thanks a lot. This was a wonderful week. That's all I can say.
Anyone else from participants?
Thank you, Anand.
Yes, ma'am. Can I speak?
Yes.
So I am Meghla Sharma, and I am from academia side. Uh, all the sessions which were organized by the Saintgits college, they were excellent and they were wonderful. Although I am from not from the industry side and I do not have that industry experience, but still, whatever knowledge I have gained through all this 6 days training program definitely will help me to use some of the use cases and build up certain applications for the education sector too. And possibly, I would like to thank all the instructors who were there, whether from the India and also from outside the country, because they have taken their time out and they have organized and scheduled such a wonderful presentations and hands-on experience for all of us. I hope I will try to implement most of the knowledge and the basics which I have gained from this particular FDP. Probably it will require more time for me to gain the complete hands-on experience, but definitely I have now a fair idea about where and what to do and what to use actually. So I thank everybody for organizing such a wonderful session for all of us. Thank you so much. Thank you.
Thank you, ma'am. Anyone else?
May I?
Yes.
This is Kushi here, and I'm attending this FDP from Gujarat. Actually, I started exploring the blockchain technology during the lockdown period only, and even I attended many webinars on the blockchain. But from this FDP, I got many new things came into picture. Like I was thinking that the blockchain is something like this, and today I have far gone deep into that particular blockchain. Even if I have attended one more FFT before that, but that was just the basic level. The use cases covered during this FDP, that was tremendous. I can't think, even if I have never thought of this, that in this areas blockchain can be applied. And now I am able to see that in which areas blockchain can be applied. So thank you very much organizers and Saintgits group for providing this opportunity to attend. And I would like to attend more such kind of sessions from the same organization in future. So I would request you to please share the session details in future as well. Thank you all the speakers.
Sure, ma'am. We will share. In October, actually, there is another training program coming. We will be sharing the details.
Thank you, ma'am.
Sir, can I?
Yes, sir.
Good afternoon. I am Professor Babu from Sarabha Institute of Science and Technology, Trivandrum. So almost all sections are very good in the sense. So more informative and lot of stuff is there. And it was arranged in a very systematic, regular manner. So first of all, let me appreciate the team behind this one, Saintgits College of Engineering, particularly Jubilant. So on behalf of all these participants, I extend my sincere thanks. In addition to this one, Gokul had done wonderfully well. And a few more are there, but I cannot say, I don't remember their exact names. But there can be some specific applications. I can tell you one is nothing but travel and tourism. Lot of issues are there because I myself is a resource person for blockchain. So I had attended this seminar just because. So whenever we go for an open group, not from teachers and all, there can be a number of questions. So certain questions may not be able to cover in a public audience of blockchain. So to get more information for those things, in general, I had attended and I got a lot of information. Thanks a lot. Thank you.
Thank you, sir.
Hello. May I?
Yes. Sure.
Yeah, just wanted to thank Jubilant for organizing such a wonderful session, because I basically come from a management background and I teach at the Narsimhoji Institute of Management Studies in Hyderabad. Some of the sessions, technical sessions, were kind of bouncers for me, because most of the technical terms and other things I was hearing for the first time. But my interest was that it is heavily used, or the ledgers are being used in banking very much, and I was interested to know. And after this, I believe that I got a some hands-on experience, and probably my interest in blockchain also has deepened. And looking forward to more such sessions from Saintgits, and I hope Jubilant will organize much more such kind of sessions. Thanks a lot for the entire team behind this 6-day workshop. Thank you for conducting this, and it was actually organized in a pretty good manner. And since the session was also spread across the so many number of days, we had some time to understand what we are talking about, and maybe spend some time in the evening to look at some of the YouTube videos, or get more information about what was being discussed. Thanks a lot.
Thank you, sir. Now, I invite Dr. Anshu Pradap, HOD of Computer Science and Engineering, Saintgits College, to felicitate about this program. Anshu, ma'am.
Hello?
Yes, ma'am.
Yes,
Okay.
audible, ma'am.
You are audible.
Very good afternoon to all. We thank all eminent speakers and participants for their willingness and enthusiasm in this STTP, followed by discussion. I was keenly observing about the feedback that we are providing to us. We are so happy about this positive feedback from you. Moreover, you are very enthusiastic for the more sessions in future. That is the happiest part in our side. I'm sure that the sessions were very beneficial, and definitely they were informative takeaways through these 6 days. Hopefully, many projects and researchers will be ideated with the fundamentals of blockchain. We welcome all participants for its advanced STTP that can be expected on October first week or second week. We will circulate the details to you. I would like to specially mention the coordinator and co-coordinators of this program, Dr. Jubilant, Dr. Arumadhu, and Engineer Gokul, as well as the other blockchain team members too. The program was well arranged with proper coordination. Thank you.
There is an announcement for the participants. The exam link will be active only for 30 minutes. Please make sure that the contents given by you are correct, as this will be used to generate blockchain generated e-certificate, and the resource materials will be shared along with the certificates to the participants. Next, I invite Dr. Jubilant J. Kirketotam, coordinator of this training program, for concluding remarks.
Thank you, listeners. I'm really happy to get all the feedback from the participants over here, as well as I'm really thankful to the management of the Saintgits College of Engineering and our HOD, Dr. Anshu Pradap, our principal, for all the support provided to us during the start of this program. And sincerely, this program was a very good success, with around 200 participants consistently and continuously participating for the program, just because of the enthusiasm and productive behavior shown by all the faculties as well as the participants. And from the depth of our heart, from the organizing team, I thank all the participants who were joining with us for this program. Also, it was a very tedious job to arrange the sessions, as you told. But all the faculties and all the speakers were coordinating and connecting us with 100% enthusiasm and interest. So we could able to, they were also cooperating to a very good extent. And sincerely, I thank Gokul Alex sir, just because in spite of all his busy schedules, we had some problems with making a Corda workshop, because our person who has already agreed had some technical difficulties to conduct the program. But taking it up as a challenge, my dear friend Gokul sir, he came over here and spent with us and took a wonderful session. I know that how much pain he has taken for helping us and supporting us. Thankfully, remembering you all for all your support, Gokul sir. And also, it would have never been a good success if I would not have got the support from the co-coordinators, Dr. Arun Madhu, Gokul Nath, technical coordinator Tibin, and also all the each and every faculty of the computer science department who were actively involving in from first to the last phase. It was purely a team effort, and I thank all the team members who were joining us in this thing. And again, we are having the next blockchain applications workshop starting from October 5th to October 10th, where some of the eminent faculties and technical experts will be participating, and that will be focusing on application-based blockchain implementation. Especially, we will be having a better focus on AI, artificial intelligence implementation on blockchain. We will be focusing a bit more, as well as we will be focusing on IoT, blockchain implementation, IoT, then agriculture, law, philanthropy, etc. Various things. So we also will be focusing much more on workshops where this we had only 3 sessions for this STTP, but we will be having more focus on the workshop next during the next workshop STTP, and require all the support from all the faculties, all the participants who are here, also from the industry as well as the academy as well as the research. I think many people were participating all over India, as well as some faculty, some of the participants in the country. We also got some good feedback from Canada and US, because they were not actively participating, but they were following through the YouTube and they were following all the
we will be retaining that WhatsApp group where we will be supporting, trying to give all the research related materials into it. Just because we are also a research team, presently having 6 research scholars and 40 supporting team. And so we are very actively into research, especially into the Hyperledger as well as Corda. So if anybody need to have any research collaborations or any research supports, please feel to contact us, and we will be active and connecting with you through the WhatsApp groups. Thank you.
Thank you, Jubilant sir.
I think we can share the question papers.
We will be sharing the exam link now.
Exam, yeah.
Participants, the exam link is available in the chat box. Please make sure to attend the exam within 30 minutes.
Jubilant sir, so from my side, once again, thank you so much for this opportunity, and I'm very delighted to take this session in front of my own teacher, Babu sir, from Sarabhai Institute of Technology. So it's my second time delivering a session in front of him, and thank you once again. Anytime in the future would like to get my support, I'll be always happy to contribute. Thanks once again, and wish you all the best to the research ecosystem.
Thank you, Gokul sir. And
Thank
also, Babu sir will connect again, sir.
Yeah, sure. So may I drop off?
Yes, please, sir. Please.
Thank you so much. Thank you, everyone. Wish you all the very best.
Thank you all.